Hey folks, so welcome back to the series where we are learning about GPU, AI, ML from an SRE perspective. So today I want to talk about different types of GPUs, right? When we talk about GPUs, there are so many models, so many series, and it's honestly really hard to keep up because the industry is evolving so fast as well. But I think if we have to categorize the types of GPU, there's briefly three categories, right? So this is more of a generalization. So the first one would be consumer and gaming GPUs, and then we'll move on to our workstation GPUs, and then we have data center GPUs. So it's mostly these three categories that different types of GPUs are, right? So today we'll talk about each of these categories and we'll understand when do we need what kind of GPU, and we'll see some examples in RunPod to see the differences in pricing and other things as well. So let's talk about the first one, which is our consumer gaming GPUs. So, a couple of examples are RTX 3090, 4090, and 5090 model. So here in RunPod, you can see that for RTX 3090, it's like the price is decent as well. It's 46 cents per hour. With 7's plan, you can go up to 33 cents per hour. Your specs are there. It's quite decent. It's a good value older option for budget AI experiments and so on. And so the use case would be, it's great for cheap experiments, and then you can run some inferencing there as well, but it's not ideal for long running production jobs where silent error and heating matters. And then the target markets are usually gamers and single user setup. And then for design wise, like the GPU cycles are designed for desktops, right? They're not designed for 24/7 high duty cycle. Like things like, the cooling fans are much smaller. The VRAM does not have error checking code in it. It's essentially just not a data center grade hardware. So you can't use these GPUs to run your production workload. And then moving on, we have workstation GPUs, which would be the RTX A series, Quadro. Some example types would be, A4000, A5000, A6000 models. Your target markets for here would be 3D designers, machine learning researchers. It comes with few features that the consumer grade GPU does not have. So that's ECC memory, certified drivers for like CAD, 3D design, and ML frameworks. It's essentially a good choice for smaller labs or enterprise teams. So let's look at the RTX 6000 models, right? So you can see it has different flavors as well. I think that's the most newest one. So as it says there, it's a next-gen Blackwell workstation GPU, provides rapid text and image generation, and then we see the pricing change as well. So now we're looking at 1.97 per hour. The older models are 70 cents per hour, and some of them are actually so popular that they're currently unavailable, right? So that tells you about the use case of these kind of GPUs. So see the difference in pricing. We do have like expensive consumer grade GPUs as well. I think if we look for them, let's look at 5090. So these are more expensive, right? But essentially, that's the point, right? So consumer grade GPUs, workstation GPUs, where it comes with these kind of features. And then finally, we have the beast, which is the data center GPUs. And examples would be A40, H100, L40, V100. There are loads of models there as well. So the target markets for these GPUs are hyperscalers like CoreWeave, all the big cloud providers. And then if you want to run your production machine learning workload, like you need these kind of GPUs. It comes with features like ECC, big support. It's optimized for 24/7 workload. You can run your production GPU clusters in these kind of GPU machine. So I kind of want to talk about MIG a little bit as well. So MIG is called multi-instance GPU support. So think of your old, server, right? Or your desktop, for example. So you would install VirtualBox on that. And then, based on your CPU, memory, and so on, you'll create virtual machines, right? So you can create 4 or 5 virtual machines based on what specs you have. So essentially you virtualize your existing hardware. So MIG is very similar, but with GPU. So you can create multi-instance GPU based on your GPU and your RAM that you have. So what you can do is, like, for example, if you have let's say 4 GPUs, you can slice it up to 1 GPU each, and then for each GPU you can assign X amount of memory. So let's say you have 100 gigs of memory, you have 4 GPUs. So you could either go one GPU, 25 gigs of memory, and then you can create 4 pods and run, 4 different types of workload, all allowing to use different types of CPUs, right? So it's essentially a, virtualization support. So these kind of tools are quite important if you're running production clusters, because you might have a workload which might need just one GPU, but it's very heavy in memory. So you create an instance like one GPU and maybe 50 gigs of memory. And then you might have other use cases where, you're okay with the memory, but you need more GPU just because of the nature of the task, right? So you might create another instance like, 2 GPUs, 10 gigs of memory. So essentially, it's that flexibility you get with data center GPUs. That's why, like for production clusters, you need data center grade GPUs. And then workstation GPUs are quite amazing too for, the features that I mentioned over here. And then our consumer gaming GPUs are, it's a different kind of market, and it's essentially not a data center grade hardware. So yeah, thank you for listening, and I hope you learned something about the different types of GPUs.